This is a continuation class from the trigonometry part 2. Okay, this class we will learn about trigonometric identities. Last two classes we learn about some of the basics of the trigonometry, and we have seen some of the angles and side ratios and some trigonometry ratios. Okay, now this class we will see some of the trigonometry identities. What is mean by identities? Okay, so it's an equation formed by identities. Okay, so it's an equation formed by the trigonometry functions. So this is the equation forming with the trigonometry ratios, and it is satisfied with all the values of. So we'll specify those values also, right? So okay, let's take the triangle ABC is the right angle, and it forms the 90 degrees at the B. Okay, so let's take at the angle C is the theta. Okay, now we know Pythagoras theorem, right? What is the Pythagoras theorem shows? It is the hypotenuse square to the equal to sum of the two other sides, right? So it is AC square equal to AB square plus BC square, right? Okay. Now we will derive one of these trigonometry ratios by just dividing the one term. Okay. Now let's do it first with BC square. Okay. Let's divide this equation with the BC square now. Okay. So first I'm dividing with BC. By dividing each one in this side, right, we'll get into the one ratio, right? That's the reason. So we do it first. Okay. We'll divide this entire equation with AC square. Okay. So it won't change anything, right? So if we divide with this AC square divided by AC square, right? I'm dividing both sides. Then it will become AB square divided by AC square, right? Then here it is BC square divided by AC square. Okay. Now, how this AC squares get cancelled. So we'll get the 1 on the left side equal to, we can write this is AB by AC, right? So whole square plus similarly BC by AC whole square. Okay. So what is AB by AC? You see here AB by AC. So it's clearly showing it is a sine theta when you write. What is the sine theta? Opposite side by hypotenuse, right? So here opposite side is to the theta is AB, right? So it is AB by AC. Okay. For AB by AC, you can write sine theta, right? So let's write sine theta here. Okay. So sine theta whole square. Okay. Plus, what about BC by AC? BC is the adjacent side to the theta angle to the hypotenuse. That is cos theta, right? So adjacent side BC by hypotenuse, it is AC, right? So for BC by AC, you can write cos theta. Okay. Cos theta whole square. Okay. In the trigonometry, okay, for this trigonometry ratios, so the square will be defined at the times sine itself. Okay. Sine square theta means it's equal to sine theta whole square. Both are same. Okay. Sine square theta, they are right like cos square theta. Okay. Equal to 1. Okay. This is the one of the identity ratios. Okay. We have derived the one identity, that is sine square theta plus cos square theta equal to 1. Okay. So for what values of this theta is valid equation? Okay. So this theta is must be between like 0 to 90 degrees, right? Okay. So now even if you put 0 in this, okay, sin 0 is 0 and cos 0 is 1. Okay. This statement is still valid. Okay. If you put 90 degrees, sin 90 is the 1 and cos 90 is 0. Okay. So even then this equation is valid. Okay. So this equation valid for the 0 to 90 all the angles. Okay. Now to get this equation, we divide this entire expression with AC square, right? Now let's divide with AB square. Now we will divide with AB square. Okay. Now then what will happen? It will become AC square by AB square equal to AB square by AB square plus BC square by AB square. Right? This is AC by AB whole square equal to AB square by AB square is 1, right? 1 plus BC by AB whole square. Okay. So, here what is AC by AB here? This is AC by AB. AB, okay. So, we know that AB by AC is sin theta, okay. But if it's AC by AB, then it's reverse of sin theta. Reverse of sin theta is cosecant theta, right? So, cosecant theta whole square equal to 1 plus, what is BC by AB? BC by AB, okay. So, for this theta, for what is the tan theta? Opposite side by adjacent side. That is AB by BC. If it is BC by AB, then it will become cot theta, right? Okay, cot theta whole square, okay. So, it can be written as cosecant square theta equal to 1 plus cot square theta, okay. This is our second identity, right? So, let's check this is valid for all the angles from the 0 to 90, okay. So, if you put cot 0, okay, and cot 0 is undefined, cosecant 0 also undefined. So, that it is not valuing for at the 0 angle, okay. That's the reason this angle will be valid only 0 to 90, but not the 0, okay. Let's write this equality here, okay. But the second expression is cosecant square theta equal to 1 plus cot square theta, okay. Here theta is between 90 and 0. It is not equal to 0. It won't valid for the 0, okay. If you put 0, its undefined number is coming, okay. That's why it is not satisfying for the 0. We have divided this equation with AC square. We got the first equation, okay. When you divide with AB square, we got the second equation. We divide with BC square, okay. So, now we will divide with BC square here, okay. Then it will become AC square by BC square equal to AB square by BC square plus BC square by BC square, okay. Now, this can be written like AC by BC whole square equal to AB by BC whole square plus BC square by BC square will become 1, okay. Now, let's see what is AC by BC. You can see here AC by BC, okay. BC by AC is the cos theta, okay. Now, AC by BC will become reverse of the cos. That is the secant theta. So, secant theta, okay. This square, as I read, we can write here, secant square theta. It will become secant square theta. Similarly, AB by BC. Because AB by BC is directly tan theta, right? So, it will become tan square theta plus 1, okay. Let's see, it will work for the 0 and 90 degrees here also, okay. What is 0 for secant 0? Secant 0 is valid, okay. And tan 0 also valid, okay. So, it works for the 0. What about the 90? 90 don't work, okay. It will become the undefined. So, this secant square theta equal to 1 plus tan square theta will work for 0 lesser than or equal to theta and lesser than the 90. Okay, it won't work for the 90 here. As it is one, so that is not coming equal sign here. Okay, so we derived the 3 equations here now. Okay, so already we discussed that. See, if you know one ratio, we can find out all the ratios, right? So earlier, by drawing the triangle, right, we did by calculating the just with the side, assume like a distance with the ratio, and we calculated the all other ratios. So by using these simple things, also we can find the other ratios by just giving the one ratio. So for example, he has given the one ratio here. Okay, let's take A as given. Okay, is given like, right, tan A is given like 1 by root 3. Okay, so how do you find all other angles? See, I'll write one more after one. See, you know that in cot A you can write directly, right? So what is the cot A? It's a reverse of the tan. So cot A is root 3. Okay, let's use this identity, right? So what is here? Secant square theta is equal to 1 plus tan square theta. Here angle is A. So this will become like secant square A equal to 1 plus tan square A, right? A is the angle here. Okay. So 1 plus, what is the tan A angle? It's a 1 by root 3. Okay. And whole square, right? So what will become 1 plus 1 by root 3 whole square is 1 by 3. Okay. If you make it equal to here, 3 is the taken common and 3 will go here. 3 plus 1 become 4 by 3. Okay. So what about secant A then? Secant A will square root of 4 by 3. Okay. That is 4 square root is 2 divided by root 3. Right. Now we know secant A is 2 by root 3. From that we know cos A. Cos A is the 1 by secant A. Right. Secant A is 1 by cos A. Cos A is equal to 1 by secant A. So cos A is the reverse of this. Okay. So that will become root 3 by 2. Okay. Now similarly, what else you want to find? If you want to find now sine, right? This sine square theta is equal to 1 minus cos square theta from that. Okay. That's equal to 1 minus, what is the cos theta is means here, right? Cos is how much? Root 3 by 2. Okay. Root 3 by 2 whole square. Okay. So if you simplify it, you'll get like 1 minus 3 by 4. Then 4 minus 3 divided by 4. That's equal to 1 by 4. Okay. Then if you go for the angle like, right, sin A is square root of 1 by 4 is 1 by 2. Okay. Now we know sin. What about the cosecant? Is the reverse of the sin, right? It will come 2. Okay. Now is the given is the tan A is the 1 by root 3 is given. Now we derived the cot here. Okay. Now we derived the cot here. Then using this identity, then we derived for the secant here. Okay. For the secant, again we got the cot here. Okay. Sorry. So from the secant we got the cos A here. Again using the first identity like sin square theta plus cos square theta equal to 1. Okay. By using this, we got sin here. And from the sin, again we got the cosecant here. Okay. So if you know any one ratio, you can find out other ratios by simply using these identities. Okay. There's a problem showing that prove that secant A into 1 minus sin A. Okay. And into secant A plus tan A equal to 1. Okay. So he is asking us to prove this. Okay. Let's take left hand side one. Okay. So by taking after this, we're going to write it everything in the sin and cos term. Okay. Then it will get simplified and we'll get some of the identities that will make it equal to 1. Okay. So that, right. So it is there in all other like, different like sin and secant, secant, tan, so many are there, right? Let's say write everything in the sin and cos terms. Okay. For the secant A, you can write 1 by cos A, right? So 1 by cos A into 1 minus sin A, right? What is secant A here? 1 minus cos A plus what is the tan A? It is a sin A by cos A, right? So we have taken the left hand side one. Okay. So keep writing here still 1 by cos A here. Okay. And 1 minus sin A. So let's take the here cos A as LCM. Okay. So if we take cos A, become 1 plus sin A, right? So cos A, if you take it here, it is 1 by cos square A, right? Cos A into cos A, cos square A. Okay. If you write this become like 1, it became right 1 minus sin A into 1 plus sin A, right? So if you take this looks like right A plus B into A minus B, right? So what you get? A square minus B square, right? So yeah, that you can just multiplying like this and sum up also, you'll get same thing. Okay. So if you simplify to that, it is a cos square A into So a square is 1 minus sine square a, right? Okay. So what do you know here? Sine square theta plus cos square theta is equal to 1. Okay. What if you send the sine square theta into other side, then look at the cos square theta is 1 minus sine square theta. Okay. So 1 minus sine square theta can be written as cos square a. Okay. Here a is the angle divided by cos square a. Okay. So both get cancelled and it is the 1. Okay. That is the right hand side. Okay. Let us take another problem. Okay. I'm just taking randomly in the book. Okay. I cannot solve everything in this class. Okay. So if you want me to solve anything specific problem, you can write in the comment section. Okay. I'll take the short video or I'll take the live classes for you free. Okay. Corrective problems, I'll take the live classes. Okay. So I'm just taking the another random problem here. Here that's given that square root of 1 plus sine a by 1 minus sine a equal to secant a plus tan a. Okay. So this is what we need to prove. Okay. Now let's take left hand side on. Okay. So what is here given? Square root of 1 plus sine a by 1 minus sine a. Okay. Now, so let's multiply top and bottom with 1 minus sine a. Okay. Why we are doing here, right? We'll get some kind of simplification here. Okay. If we do it this way, okay, let's multiply with 1 plus sine a. Okay. Let's multiply with 1 plus sine a. Okay. 1 plus sine a. You can check with by multiplying with 1 minus sine a also and see, okay, what happens. It's okay. Whether you are able to derive it or not. Okay. If you are not, then again going back and see 1 plus sine a will work. Okay. So let's take this square root here. Okay. What is 1 plus sine a into 1 plus sine a? 1 plus sine a whole square. Okay. So here 1 minus sine a and 1 plus sine a, what we can write here? It will become right a plus b into a minus b. It's right a square minus b square. B square is a sine square, right? Sine square a. Okay. Come down. Okay. The square root of it is 1 plus sine a whole square divided by, okay, 1 minus sine square a. Okay. What you can write here? 1 minus sine square a. Sine square theta plus cos square theta is 1. Okay. Now 1 minus sine square theta is cos square theta, right? So cos square theta. Okay. From this you can write. So here 1 plus sine a whole square will become, and square root will get cancelled. So it is 1 plus sine a divided by the cos. Sorry, it's a. Okay. A is the angle here. So cos square a will become cos a. Okay. If you write here, it will become like 1 by cos a plus sine a by cos a, right? So here dividing with individual less term. Okay. 1 by cos a and sine a by cos a. What is 1 by cos a? Is a secant a. Sine a by cos a is tan a, right? So this is the right hand side one. So here you need to know small tricks to do simplification. Okay. Well, if you keep doing your thing, you will get this kind of ideas naturally. Okay. Thank you. Okay. So if you have any questions and doubts, okay, write in the comment section. Okay. Please, if you like the video, press the like button and share it with your friends. Thank you.